So for number 7, this is an inequality, but when you're doing inequalities like this, what we really need to know is when does this turn from positive to negative? And so we really need to find out the zeros of a function that would look like this. If we can find the zeros of this function, then we can know that when it equals 0, then that's when it's going to change from true to false in our inequality. So we do a piecewise function for this. And remember, on our piecewise functions, the way that we do them is we look for the zeros of the absolute values. And so that's at 2 and 5/3 are the two zeros. And so we're going to say from for our piecewise function, we're going to say from negative infinity to 5/3, from 5/3 to 2, which is a really small gap, and then from 2 to infinity. Well, from negative infinity to 5/3, both of these would be negative. If you picked any value inside that region, you'd get negative values inside the absolute value. So we have to do the opposite of those. So negative 2x minus 4. And then what you're really doing is minus a negative 3x minus 5. But notice that you got a minus a negative, so that's just going to turn into a positive. In between these, the 3x minus 5 becomes positive, but then 2x minus 4 is still negative. And so it's going to be negative 2x minus 4 minus 3x minus 5. And then in the last region, they both are going to be positive, so you're just going to do 2x minus 4 minus 3x minus 5. Now you got to be careful here with your negatives. And so when you do that, this becomes positive, and so you get negative 2x plus 3x gives me x. Positive 4 minus 5 gives you negative 1. For the second one, you get negative 2x minus 3x is negative 5x. Positive 4 plus 5 is positive 9. And then for the last one, you get negative x plus 1. So when we look at these, we find out what the zeros of each of these parts of this function are. And so this one happens at x equals 1. This one happens at x equals 9/5. And then this one happens at x equals negative x equals 1 as well. Well, technically this one wouldn't work because 1 is not inside this region, but it doesn't matter because we got it up here as well. And what we find out is this function equals 0 at 1 and then also at 9/5. 9/5 is inside this region. So that means we need to consider this at 3 places for all values from negative infinity to 1 and then from 1 to 9/5. So you've got to think about it as an equation first to find out when does it equal 0. Then you have to consider the inequality. So we check these regions. If I put a 0 in for this, I would get 4 is greater than 5, which is not true. So that region is not true. If I put in 1.5, I would get, this would be negative 1, absolute value of negative 1, which is 1, greater than 0.5. That is true. So our inequality is true from 1 to 9/5. When I pick a number bigger than 9/5, like say 5, I get 6 is greater than 10, which is not true. And so this region is not true. So this is just from 1 to 9/5. It's strictly greater than, and so it's going to not be equal to, because they're equal. They would be equal to each other at where it equals 0. And so it's just 1 to 9/5 is your answer.